A 0.1034 gram sample of an unknown compound is subjected to a combustion analysis, producing 0.2351 grams of carbon dioxide and 0.0962 grams of water. What's the empirical formula of the compound? Well, firstly, we're going to find out how many moles of carbon dioxide and how many moles of water do we have. So firstly, to find out how many moles of carbon dioxide, we need their molar mass. So we've got 12 and 2 times 16, which is 44. So 0.2351 divided by 44, we get an answer of 0.00534. And then water, we've got 2 times by 1 plus 16 gives us 18. So how many moles of water do we have? 0.0962 divided by 18. Well, that's equal to 0.00534 as well. Now, we've got, for each mole of water, we actually end up getting 2 hydrogens. So we need to double this value now. So 0.00534. Okay, multiply that by 2. That's going to tell us how many moles of hydrogen we have. So 0.01068. Okay, next up now we've got carbon here, we've got hydrogen here. So we've got 0.00534, and on this side we've got 0.01068. We're going to divide it by the smallest number, which is for the carbon. So 0.00534, and on the other side 0.00534. We get a ratio here of 1 to 2. So our empirical formula is CH2. Cyclopropane is a compound of carbon and hydrogen that is used as a general anesthetic. When 1 gram of the substance was burned completely in oxygen, 3.14 grams of CO2 and 1.29 grams of H2O were produced. What's the empirical formula of the compound, and what's the molar mass of the cyclopropane that was produced? I'm just going to move this over here. Okay, so firstly, just like the previous question, we need to work out how many moles of CO2 and how many moles of water are produced. So 3.14 divided by 44, 3.14 divided by 44, we have got 0.0714 moles of CO2, and then 1.29 divided by the molar mass of water, which is 18. So 1.29 divided by 18, we get 0.0716. Okay, now because H2O, water is contributing 2 hydrogen atoms, we need to double this. So we're going to get 0.1433 moles of hydrogen. So now, if we look at the ratio of carbon to hydrogen, well, 0.0714, and we've got 0.1433, divide by the smallest number, which is the carbon, and we find we get a 1 to 2 ratio. So the empirical formula is CH2. Now they tell us what's the molar mass of cyclopropane is 42 grams per mole. Well, carbon is 12, and we've got 2 times by 1, which gives us 14. 42 divided by 14 is 3. So we should have C3H6. And in fact, it's 3 carbons bonded like this, and each carbon has got a hydrogen like this. So this is what cyclopropane actually looks like. When 3.10 grams of a compound containing only carbon, hydrogen and oxygen was completely burned in oxygen, 4.40 grams of CO2 and 2.70 grams of H2O were produced. What is the empirical formula of the compound, and what is the molecular formula if the molar mass is 62.1 grams per mole? Now let me just move this over here. Okay, so firstly, like the previous questions, we're going to look how many moles of carbon have we got, how many moles of hydrogen have we got, and then what we're going to do is work out how much oxygen we've got as well. Then we're going to use that to work out the empirical formula for the compound. Then we're going to use the molar mass to give us the molecular formula. So firstly, we've got 4.04 divided by 44. That gives us 0.1 moles of CO2. Then 2.70 divided by 18. That gives us 0.15 moles of H2O. Now remember, that's H2O, so by doubling it, 0.3 moles of hydrogen. Now 0.1 times by the mass of carbon, which is 12, plus 0.3 times by 1. This is going to tell us the mass of everything we've got so far, which is 1.5 grams. Now we've got 3.1 grams. So 3.1 minus 1.5 is going to tell us how much oxygen we've got. So 3.1 minus 1.5, and we get an answer of 1.6. So we've got 1.6 grams of oxygen. How many moles of oxygen have we got? Well, 1.6 divided by the molar mass of oxygen, which is 16, is 0.1. So now if we look at the top here, we've got carbon, hydrogen and oxygen. So carbon, we have got 0.1 moles. Hydrogen, we've got 0.3, and oxygen, we have got 0.1. So dividing it by the smallest number, which is the same for carbon and oxygen, so 0.1, we find a ratio of 1 to 3 to 1. So we've got CH3O, and finally we know our molecular mass is 62.1. So this would be 12, this would be 3, and oxygen would be 16, which gives us 31. So 62 divided by 31 is going to be 2. So everything here, to find the molecular formula, we're going to have to double. So our final answer for the molecular formula will be C2H6O2. Question number 4. When 0.100 moles of a compound of carbon, hydrogen and nitrogen was burned completely in oxygen, 26.4 grams of CO2 were produced, 6.30 grams of H2O were produced, and 4.60 grams of NO2 were produced. What's the empirical formula for the compound? Okay, again, let me just shrink this up over here. So, firstly, like we've done with previous questions, let's work out how many moles we've got of each. So firstly, let's do the carbon dioxide. So 26.4 divided by 44. 26.4 divided by 44, we get 0.6 moles of CO2. Then water, 6.30 divided by 18, and we get 0.35 moles of H2O. And then remember, we want to know how much hydrogen we've got, so we can double this, and we find we've got 0.7 moles of just hydrogen by itself. And then finally the nitrogen, well, we've got 4.60 divided by nitrogen, so nitrogen is 14, and we've got 2 oxygens, which is going to be 32. So we're going to have 4.6 divided by 46, which is going to give us 0.1. Now up here, let's have a look. So we've got C, H and N. So we've got 0.6 moles of carbon. How many moles of hydrogen? We've got 0.7, and of nitrogen we've got 0.1. So dividing by the smallest number, which is nitrogen, we're going to get our empirical formula for the compound, which is going to be 6, 7 and 1. So C6, H7, N, and that's our final answer.